American aerospace engineering consistently pushes the extreme boundaries of physics. We build fifth-generation stealth fighters that vanish from radar, and hypersonic glide vehicles capable of striking anywhere on the globe in minutes. Yet none of these advanced machines would leave the ground without the inclusion of a highly obscure, practically invisible element, niobium. In heavy metallurgy, adding an exceptionally tiny amount of niobium, often just 0.01%, produces a massive structural reaction. The atoms pin the grain boundaries during hot rolling, altering the molecular lattice. This drops total weight while drastically increasing tensile strength. This diagram shows exactly where those high-strength, low-weight properties are deployed across multi-domain defense platforms. Niobium is an absolute requirement for the superalloy airframes of guided missiles, the reinforced steel flight decks of aircraft carriers, and the titanium niobium armor plating on main battle tanks. But despite its mathematical necessity for American military force projection and economic stability, the foundational supply chain supporting these weapons is entirely hollow. The United States has extracted exactly 0 commercially viable ounces of niobium from its own soil since 1959. To feed an immense domestic appetite of roughly 8,400 tons per year, the nation relies on 100% net imports. Every single ounce is pulled from a foreign mine and shipped across the ocean. Because there is no active extraction at home and no geological buffer, the domestic manufacturing sector operates completely exposed to global supply shocks. Niobium is not a standard imported commodity. Its absence from U.S. soil transforms it into a glaring, catastrophic single point of failure for national security. Why can't engineers simply swap it out for a different metal when building extreme environment components like jet engine turbines? The answer lies in quantum mechanics. Niobium is classified as a primary refractory metal. A refractory metal is a class of elements recognized for their exceptionally high resistance to heat and wear. This resistance comes from the optimal half-filling of its d-band electrons. These are the specific outer shell electrons that dictate the strength of the bonds between metal atoms. This atomic configuration creates immense cohesive energy, giving pure niobium an absurd melting point of 2,477 degrees Celsius. When you compare its specific weight to heat resistance ratio against heavier refractory metals like tungsten or rhenium, the engineering constraints become obvious. Swapping niobium for tungsten would provide the exact same heat resistance, but cause an unacceptable weight increase, destroying a fighter jet's range and payload capacity. This highly specific quantum mechanical profile dictates that there is absolutely no viable chemical substitute for niobium in aerospace superalloys, without incurring severe performance and fuel efficiency losses. When we zoom out from the atomic scale to the global map, we find that the geographic origins of this indispensable element are overwhelmingly dominated by a single nation, Brazil. This chart shows the extreme oligopoly at play. Brazil controls roughly 90% of the global production share and supplies the vast majority of all U.S. imports. This dominance is the result of a highly specific geological process. Over millions of years, intense tropical rainfall washed away highly soluble surface rock over massive carbonatite intrusions, leaving behind concentrated, mineral-rich red dirt. Geologists refer to these as lateritic soils. Lateritic soils are heavily weathered, iron-rich dirt types formed in hot, wet, tropical environments. Here, they are highly concentrated with a mineral called pyrochlore. Pyrochlore is the specific crystalline mineral group that serves as the world's primary source of niobium. Because this ore sits on the surface, it is vastly cheaper to open pit mine in Brazil, compared to Canada's operations, which rely on hard rock underground block caving. Block caving is a massive underground mining technique where engineers undercut a huge ore body and let it collapse under its own weight. A massive quirk of tropical geology handed a single South American nation a near-absolute monopoly over a material that the rest of the industrialized world requires to survive. This extreme bottleneck generates intense geopolitical friction and paranoia within the halls of the U.S. government. You can see the exact impact of this vulnerability in recent U.S. trade policy. When the Trump administration implemented heavy 40% tariffs on a wide range of Brazilian goods, niobium was deliberately and explicitly exempted. The stark logic behind this targeted exemption is simple. Because the U.S. lacks both domestic production and viable technical substitutes, taxing niobium imports would act as a direct, immediate financial penalty on the United States military. This rare policy carve-out proves that even the most aggressive geopolitical trade strategies must bow to the absolute physical necessity of this specific metal. The geopolitical vulnerability is actually worsening. Inelastic demand for niobium is expanding rapidly beyond military steel and fighter jets. Inelastic demand means buyers will continue to purchase the exact same quantity of a material, regardless of how high the price spikes. Extreme purity niobium oxide is now strictly required for the emerging tech economy, from fast-charging electric vehicle batteries to superconducting radio frequency cavities. These are ultra-cold metallic resonant chambers used to accelerate subatomic particles with zero electrical resistance, an essential component for both quantum computing and advanced particle accelerators. These escalating industrial pressures are exactly why the Pentagon and the U.S. Geological Survey maintain niobium on the official critical minerals list. The government treats this supply chain gap as an active, blaring distress signal. Until domestic extraction and processing initiatives, such as the proposed Elk Creek facility in Nebraska, finally secure financing and come online, American technological supremacy will remain uncomfortably tethered to a single South American supply chain.